Okay, so here we have been given the question 15. Match list 1 with list 2 and select the correct answer using the code given below the list. So water BF3 I3 minus SF4. So for water, let us calculate the steric number. Total valence electron count is what? 2 into 1. 1 is the valency of hydrogen. 6 is the valency of oxygen. Total number is 8. When the number is 8 or less than 8, we divide by 2 to find out the steric number. So over here it is going to be 4. Now out of this 4, 2 are going to be bond pairs. That is the OH bond. So that means the other has to be the lone pair, giving you total 4 electron pairs. Hybridization is sp3. That means for water, these two bonds are your sigma bonds and these two will be your sp3 hybridized lone pairs. So water is having the shape of angular. So water means angular. Let's do BF3. Total valence electron count will be for boron 3 plus for fluorine 7 into 3. Total is 24. Number is greater than 8. So we have to divide by 8. This will go 3 times. Steric number 3 means sp2 hybridization. All will be bond pairs over here. Okay. So BF3 is basically having this type of a shape, which is trigonal planar. So that means BF3 is option 3. What about I3 minus? Let's check. Total valence electron count will be 7 into 3. For the negative charge, we will add 1, and that will give you again 22 electrons. Number is greater than 8. Divide by 8. So this will go twice. That means 16. Take out 6 from here. Number is greater or less than 8. So divide by 2. So you get 3. This is your bond pair. That is your lone pair. Total electron count is 5. Steric number 5 means sp3d. However, for the structure of iodine, we have to follow Bend's rule, in which lone pairs are taken out to be having more s character, so they will be lying on the bonds having more s character or orbitals having more s character, that is the sp2 lobes. So the lone pairs will be placed in the equatorial plane and the iodine has to be placed in the axial plane. So out here, ignoring the lone pairs, we will say the structure of I3 minus is going to be linear. So that means SF4 is obviously seesaw. So having considered all that, our correct option over here is going to be option 2. Next, in which of the following molecules all the bond lengths are not equal? In the previous example, we have seen BF3 is having this shape. Okay. Similarly, if we calculate the shape for BF4 minus, we will say for BF4 minus, so this is basically triangular planar, all the bonds are having equal length over here. Okay. For BF4 minus, we will say it is total valence electron count is going to be 3 plus 7 into 4 plus 1 for the negative charge over here. So we are getting an electron count of 28. Number is greater than, so not 28. Okay, it's basically 32. So number is greater than 8. So we divide by 8, and so we get 4 as the steric number, all of them are bond pairs. So BF4 is basically, we will say, a tetrahedral structure in which all the bonds are of equal length, okay, because they are all sp3 lobes combining with the fluorine. For XeF4, let us calculate TVC, total valence electron, is going to be 8 plus 4 into 7, and that is going to give you around 36. Number is greater than 8, same rule follow. So it is 32, we are getting 4. There are 4 bond pairs, obviously this one, and this is less than 8, so divide by 2. So these are your lone pairs, 6 electron pairs. That means hybridization will be sp3d2. Okay, whenever the steric number is 6, we say hybridization is sp3d2. So that means the shape of the molecule will be something like Xe. Place the 4 fluorines in the square plane of the octahedron, and the 2 lone pairs are going to be above and below. And so here also we see all the bonds are of equal length. For the SF4, let us calculate total valence electron count is going to be 6 plus 7 into 4. Okay, that means 28 plus 6 is going to be 34. Number is greater than 8, so you divide by 8. You get over here 4. This is 32. 2 will be cancelled by 2. Okay, so this is like 1. Total number of electron pairs is 5. This is the bond pair, that is the lone pair. So this means basically sp3d2. Again, if you use the Bend's rule, which states lone pairs should occupy the equatorial bonds and the most electronegative atoms should occupy the axial bonds. So this is the equatorial plane in which we have the lone pair electron and the fluorine. 2 go over here and the rest 2 fluorine go over here. Axial bonds are longer than equatorial bond. Axial bonds are greater than equatorial bonds. So obviously this molecule is having non-equal bond lengths, and our answer will be over here, this. Okay.